Granulation is the active process of forming into grains or granules. Granules typically have a size range between 0.2 and 4.0 mm depending on their subsequent use. Chemical industry. In the chemical industry, granulation refers to the active process in which large objects are cut or shredded and remelted into granules or pellets. Pharmaceutical industry. In the pharmaceutical industry, granulation refers to the active process in which primary powder particles are made to adhere to form larger, multiparticle entities called granules. It is the process of collecting particles together by creating bonds between them. Bonds are formed by compression or by using a binding agent. Granulation is extensively used in the manufacturing of tablets and pellets, or spheroids. The granulation process combines one or more powder particles and forms a granule that will allow tableting or the spheronization process to be within required limits. This way, predictable and repeatable process is possible and quality tablets or pellets can be produced using tableting or spheronization equipment. Purpose. Granulation is carried out for various reasons, one of which is to prevent the segregation of the constituents of powder mix. Segregation is due to differences in the size or density of the component of the mix. Normally, the smaller and or denser particles tend to concentrate at the base of the container with the larger and or less dense ones on the top. An ideal granulation will contain all the constituents of the mix in the correct proportion in each granule, and segregation of granules will not occur. Many powders, because of their small size, irregular shape or surface characteristics, are cohesive and do not flow well. Granules produced from such a cohesive system will be larger and more isodiametric, both factors contributing to improved flow properties. Some powders are difficult to compact even if a readily compactable adhesive is included in the mix. But granules of the same powders are often more easily compacted. This is associated with the distribution of the adhesive within the granule and is a function of the method employed to produce the granule. For example, if one were to make tablets from granulated sugar versus powdered sugar would be difficult to compress into a tablet and granulated sugar would be easy to compress. Powdered sugar's small particles have poor flow and compression characteristics. These small particles would have to be compressed very slowly for a long period of time to make a worthwhile tablet. Unless the powdered sugar is granulated, it could not efficiently be made into a tablet that has good tablet characteristics such as uniform content or consistent hardness. Techniques. In the pharmaceutical industry, two types of granulation technologies are employed: wet granulation and dry granulation. Wet granulation. In wet granulation, granules are formed by the addition of a granulation liquid onto a powder bed which is under the influence of an impeller. In a high-shear granulator, screws. In a twin-screw granulator, or air. In a fluidized bed granulator, the agitation resulting in the system, along with the wetting of the components within the formulation, results in the aggregation of the primary powder particles to produce wet granules. The granulation liquid, fluid, contains a solvent which must be volatile so that it can be removed by drying and be non-toxic. Typical liquids include water, ethanol and isopropanol, either alone or in combination. The liquid solution can be either aqueous-based or solvent-based. Aqueous solutions have the advantage of being safer to deal with than solvents. Water mixed into the powders can form bonds between powder particles that are strong enough to lock them together. However, once the water dries, the powders may fall apart. Therefore, water may not be strong enough to create and hold a bond. In such instances, a liquid solution that includes a binder Pharmaceutical glue is required. Povidone, which is a polyvinyl pyrrolidone, PVP, is one of the most commonly used pharmaceutical binders. PVP is dissolved in water as solvent and added to the process. When PVP and the solvent, water, are mixed with powders, PVP forms a bond with the powders during the process, and the solvent, water, evaporates, dries. Once the solvent, water, has been dried and the powders have formed a more densely held mass, then the granulation is milled. This process results in the formation of granules. The process can be very simple or very complex depending on the characteristics of the powders, the final objective of tablet making, and the equipment that is available. In the traditional wet granulation method, the wet mass is forced through a sieve to produce wet granules, which is subsequently dried. Wet granulation is traditionally a batch process in the pharmaceutical production. However, the batch-type wet granulations are foreseen to be replaced more and more by continuous wet granulation in the pharmaceutical industry in the future. The shift from batch to continuous technologies has been recommended by Food and Drug Administration. This continuous wet granulation technology can be carried out on a twin-screw extruder into which solid materials and water can be fed at various parts. In the extruder, the materials are mixed and granulated due to the intermesh of the screws, especially at the kneading elements. The original mathematical model for these type of processes is in integral differential equations. However, these model can be reduced down to an ordinary differential equations using method of moments. In these reduced order models, the probabilistic moments of the output's distribution are the state variables of the system. Dry granulation. The dry granulation process is used to form granules without using a liquid solution because the product granulated may be sensitive to moisture and heat. Forming granules without moisture requires compacting and densifying the powders. In this process, the primary powder particles are aggregated under high pressure. Swaying granulator or a roll compactor can be used for the dry granulation. Dry granulation can be conducted under two processes. Either a large tablet slug is produced in a heavy-duty tabletting press, or the powder is squeezed between two counter-rotating rollers to produce a continuous sheet or ribbon of materials. Roller compactor, commonly referred to as a Chilsonator, which received its name from its inventor, Francis Xavier Chilson. When a tablet press is used for dry granulation, the powders may not possess enough natural flow to feed the product uniformly into the die cavity, resulting in varying degrees of densification. The roller compactor, granulator compactor, uses an auger feed system that will consistently deliver powder uniformly between two pressure rollers. The powders are compacted into a ribbon or small pellets between these rollers and milled through a low shear mill. When the product is compacted properly, then it can be passed through a mill and final blend before tablet compression. Typical roller compaction processes consist of the following steps. Convey powdered material to the compaction area, normally with a screw feeder. Compact powder between two counter-rotating rolls with applied forces. Mill, resulting compact to desired particle size distribution. Roller compacted particle are typical dense, with sharp-edged profiles. See also: grain size, granular material, particle size distribution, pelletizing. Sources: Handbook of Pharmaceutical Granulation 3rd edition. Editor: Dilipem, Parekh. Pharmaceutics, The Science of Dosage Form Design. M. E. Alton 2nd ed. Pharmaceutical Dosage Forms and Drug Delivery System. Lloyd V. Allen, Nicholas G. Popovich and Howard C. Ansel 8th ed. Lachman Leon. Industrial Pharmacy. Special Indian Edition. CBS publishes.